Programming Throwdown, Episode 104, DevOps and Site Reliability with Matt Watson. Take it away, Jason.
Hey, everybody. So if you remember from, I'm on the spot now because I didn't plan ahead. I think it was episode 96. We talked with Rob Zuber from Circle CI about testing. We talked all about all the different forms of testing and how important that is. But at the end of the day, if you're going to have a scalable system, if you're going to service a lot of folks, you're going to have to do more than just write really solid unit tests and integration tests and all of that. I mean, you have to build something that's reliable, that can heal, right? And you have to build a lot of social and human processes to make all of that work and to keep all of these really popular websites that you go to every day stable. And so we have Matt Watson here, who's the CEO and founder of Stackify, who's had a ton of experience in this field and is going to taking some time to really share with us how that whole process works and how these websites do stay up for all of that time. And so, Matt, it's really good to have you on the show. How are you doing?
Great, absolutely. Thanks for having me.
Cool, awesome. Are you hanging tight with the lockdown? I don't know what area you're in, how severe the lockdown is right now for you.
Yeah, so Stackify is based in the Kansas City area. Half of our employees live in Missouri and half live in Kansas. For those who don't know the trivia about Kansas City, it's right on the border.
Oh, that's right, yeah.
But yeah, everybody's doing good and working remotely, and has been no big deal for us. Coronavirus is definitely here, but it's not currently spiking like it is in some other areas. But everybody's trying to play it safe though.
Yeah, that makes sense. Yeah, it's spiking pretty bad. Actually, both Patrick and I live in Texas and in California, but hopefully they kind of figure out ways to get it under control. But cool. So yeah, why don't you start with kind of an intro about yourself? How did you get into this sort of field, and what sort of inspired you to take the leap from whatever you were doing at the time to say, I want to start a company, build a company around DevOps and site reliability?
Yeah, so I am now 39 years old. Yesterday was my birthday, and
happy birthday!
So thank you. I actually started my first software company when I was 22 years old, and it was a company called Vin Solutions, and that company grew really fast. It was actually, it's weird to think about it now, but was really kind of on the forefront of SaaS, software as a service companies. Mm-hmm. And back then crap was hard. Like if we needed more servers, like we're racking servers and installing VMware and like dealing with all that kind of crap. And, none of that was fun and none of it was easy. And it was before the cloud, right? Before AWS and Azure and all these things. And
wait, so did you have a warehouse or something? I mean, how did you,
we just used a local data center. I mean, it was just a local Kansas City data center, but so that company really grew really fast, and in 2011 we sold it. But when we sold it, I had about 40 people that worked for me in IT. Most of that was software development, but we had every challenge in the world from, how to scale this thing, the performance and bugs and trying to build new features. And like, we had all the problems as a startup, right? Mm-hmm. And, my goal when I left there and started Stackify was to build a set of tools and a platform that would help developers better understand how their applications are performing, how to troubleshoot basic problems, view errors, view log files, just basic kind of day-to-day stuff, which is a lot of kind of DevOps, SRE kind of stuff these days. But the problem I had back then is it felt like myself and the 3 or 4 other developers that were the most important people in the whole company spent all day long looking at log files and trying to solve bugs in production, right? When we had like 40 other developers, but they just didn't have the knowledge, the tools, the security access, just didn't have all of those things to really help troubleshoot things. And we just didn't have the tools. So, I mean, that was originally the goal was, how do we build a set of tools to help developers troubleshoot basic problems, so that the lead developers don't spend all day doing it.
Yeah, cool. So let's try to unpack, it's actually, there's a lot of complexity around just getting some diagnostics into your hand, right? So you have this data center. Now most people are using AWS, but let's say you've rented out a portion of this data center and you have some servers on it. How do you go from 100, 1,000, 10,000 machines serving some website to being able to look at something on your computer and say, oh, yep, this is bad. This log line is bad. How does that end-to-end process look like?
Well, so I mean, all of these things have changed a lot over time, right? And it used to be, developers and system administrators would set up all these machines, and you'd have a load balancer, and you could log into the server, and of course you have all the security access, concerns with all of those things, right? But now you fast forward to today, and like servers aren't even a thing. We have containers, or we have serverless applications, and now you're deploying a container somewhere, and there's one to many of those instances of that container. And yeah, to your point of like, well, how do I get the log files off of a container?
Right.
Like it's like there's more and more levels of abstraction from a developer or anybody in IT to troubleshoot these things. There's multiple layers of automation and abstraction and all of this stuff, which makes it more and more difficult to troubleshoot some of these things because like we use Microsoft Azure at Stackify, and we were recently trying to troubleshoot something, and I had to figure out how to SSH into a container. That was interesting.
Yeah, right.
And by the way, I'm an old Microsoft developer basically who hates everything command line related. And so I'm not an old dog, but I feel like an old dog now being forced to learn this Kubernetes and all this stuff and Linux and I'm like, God, why is this so complicated? Can I just like RDP into the box and like troubleshoot some things? It'd be a little easier. But
totally.
The only way we get access to these things today is to get all the data off the servers, right? So like log data, we got to get the logging data off of the servers, the containers, the serverless app, whatever type of app it is, wherever it's deployed, you've got to get that data off of there and get it to, a centralized logging solution, which there are a lot of those. Stackify is one of them. We do centralized logging, but there's things like Splunk or, all sorts of solutions that you can throw all of your logging data into. Elasticsearch is another popular one.
So how does that work? So if someone wants to use any of these, let's say Stackify, they built some Docker container that has their website, business logic, and then how did they connect that to Stackify? They write as part of their code, like you have something in every programming language. So if someone's using, let's say C++ or Node.js or something, they have some line that says, log this to Stackify, or like how does that work?
Yeah, most developers in their applications use some form of standard logging framework, right? So in .NET, that's Log4j, and it's Node.js, it's Winston, in .NET, it's nlog or Log4net, or so they use these standard logging frameworks, which help you decide if you want to log to disk or log to, syslog or Windows Event Viewer or rolling files on disk, all these different things, right? And so most of the way you do this is they support different targets or appenders that are sinks. They call them different things, but basically they're like extensions that allow you to just change your config file to say, you know what, I want to send this logging data to this third-party source now, which could be Stackify or Elasticsearch or whatever the thing is, right? So it's usually a small configuration change. But
got it. That makes sense.
That's only one type of logging, right? You've also got logging from like the web server. If you want to get like logs from Nginx or Apache or IIS, like that's a different kind of logs, like access logs. And then you've got server logs, which could be things from syslog or Windows events. And then now you get to like Kubernetes, and Kubernetes has its own logs. Like everything has logs. There's logging data for everything, right?
Oh, I see. And so it's a combination of, if you're the one writing the app, then you configure it, in your app. But if there's something like the Windows syslog or the Linux syslog, in that case, there's like a Stackify, maybe daemon or something that trolls that and logs it for you or redirects it for you.
Yeah, and as we talk about DevOps sort of stuff today, the challenge is, as a developer, you just want to write code and you can add your own logging and stuff like that, right? But then how you deploy your application and then, install it in dev and QA and some pre-production environment and production and the automation of all that and all the configuration and all the settings and all the diagnostics. And that's just like a whole different world that most developers don't want to deal with or don't know how to deal with, right?
Yeah.
And I think that's where, DevOps has kind of come in, and there's people who specialize on those things, and it's its own craft.
Yeah, that totally makes sense. Like, so, it sounds overwhelming. There's, a lot of questions here. One is, how do you handle, there's just so much data, right? If anyone right now, if you're running, and I have to admit, I'm on the other side of the table. I've only ever done Linux development. So I don't know too much about PowerShell or Windows, but anyone on their computer, running Linux can type D message, and you'll just see this huge flood of all these things. Oh, your Wi-Fi driver is telling you something, and thousands of lines just for the computer to start, and your Windows server is doing this, and everything's doing that. And so that's a ton of information when even if nothing really interesting is happening on the computer, right? And so you multiply that by all the computers that it takes to service whatever this website is or this web service is, and it's just overwhelming, right? How do developers even know if something's going wrong before it's too late, right?
Well, the logging data you're mentioning is really only probably like 1/4 of the information that you need. There is so much other information that you need that doesn't even come from your logging. So for example,
like what?
Like metrics. So what is the CPU and memory of the server, or custom metrics for your software? Let's say, for example, at Stackify we receive log messages, right? So if we want to know how many log messages per minute are we receiving, that's a metric, right? So
that makes sense.
Software produces a lot of different kinds of metrics that can be specific to the application, which could be things like garbage collection or the number of threads being used, like all sorts of diagnostic things, like how many SQL connections do we have open, all that sort of stuff, right? But then you've got things like CPU and memory and system load and disk space and like all that kind of stuff, right? So you have all sorts of metric data that is at your disposal. But then most people these days use some sort of profiling technologies like application performance management, APM kind of tools, which is what Stackify does. So we profile their applications in production and can tell them, how many times a specific transaction happens, all the things that application talks to. So it's like, oh, your application uses this SQL database and it uses Redis and this queuing and this, third-party web service and, all the different things your application connects to, right?
So is that hooked into the OS? How does that work? Like how do you know without the developer telling you if they're accessing a SQL server?
Yeah, so APM products like Stackify, like application performance management, and there's other companies that do this, like New Relic and App Dynamics and other companies. If people are listening are familiar with those type of products and companies, the way all of them work is they basically inject themselves in at runtime. So while the application is running, they basically manipulate the code, kind of inject themselves into the application while it's running, and then are able to instrument those different things to know like when a SQL query is being called, how long it took that call to happen, when an external service is being, HTTP service is being called. So that's done through byte level code level injection into the app at runtime. So what kind of programming language do you use for your work?
Yeah, so I typically use Python, and so the front end work that I have done has been mostly using Flask or Django or these things.
So for scripting languages like Python and Node.js and Ruby, the APM part of it is actually done with what's called monkey patching. So basically, when you execute a query, our library like overrides the behavior of that method with what's called monkey patching, and then our method gets called instead, and then we call the original method. So we're able to add
that makes sense.
Instrumentation. So it's called monkey patching, which I didn't even know that word. It was a weird.
Yeah, I've done this before for there was an application where the person used just straight Python prints, and I was kind of in a hurry trying to debug something, and so I just created my own print. Yeah. That called the original print, but then also did some other analysis.
There you go.
And
that's how it works.
Yeah, when they call the print, they didn't expect to call my print, but it's still, as long as you don't really change what returns from the print, it should work like normal.
There you go. So that's how this APM kind of technology works on the scripting languages. And it works similar for .NET and Java and stuff, but it's, those languages are compiled into bytecode, right? So that sort of manipulation has to be done in the bytecode, the compiled code.
Yeah, that sounds really hard. I put that in the hard category.
It is really, really, really add a bunch of expletives, curse words, complicated. Very complicated.
Yeah, I can't even imagine. I mean, I've seen some of these like disassemblers and things like that where you give it an executable and it'll turn it into C code. But that's about the extent of my experience in that area, and it looked really difficult, especially you have to do it without knowing what the app developer is going to do. Like you basically have to do it in a way where it works with every app and there's no corner cases.
Exactly. And that's like rule number 1 at Stackify is we don't crash other people's applications. We don't add a bunch of performance overhead. And actually, so we support 6 programming languages at Stackify for what we do. And actually in .NET, a large part of the profiler is actually written in C code. Mm-hmm. And then so we had to know C to actually write a .NET profiler, which is kind of funny. And same thing actually, I'm sorry, it's C++ technically, I believe.
Right.
But then in PHP, it's also written in C as well. So, and then Java actually is written in Java. So it's actually a lot easier because of that. But I don't know if you've ever done any programming in C, but it's a nightmare. Yeah.
So Patrick actually is the CX. He had to step out. I saw his kids coming barreling through the door. So, but he's done a lot of C, a lot of embedded programming, and I mean that terrifies me. One time I did, and I totally botched it. But they asked me to do work on a DSP, and it was super difficult. I mean, first I wrote it the way I would write high level C++ code. And it almost immediately ran out of memory. Patrick, we were just talking about having to use C to do like a C to C# interop to get automatic, to get code injection basically into C#. That stuff is brutal, but I mean, I think there's a lot of intellectual capital that you've built if you can make that work, because you need a very specific expertise.
Well, and you talk about just software development in general and how it's changed over the years, right? Like programming in Python or Java or a lot of these other more modern languages is infinitely more easy than writing C++. And honestly, these days, I don't even think really a computer science degree is really all that useful to learn like about pointers and bubble sorts or like compiler theory or any of that. It's like completely useless unless you want to be a C++ programmer. then it is like really critical knowledge that you need to have. But for a lot of the more modern stuff, like it's just so much easier not having to worry about all that crap.
Yeah, I mean, we'll totally pick your brain a little bit later. We'll put a bookmark on that because I'd love to talk more about that is the most popular question we get into the show is should I go back to college, right? And yeah, definitely. The TLDR, I kind of agree with you, but we'd love to. Let's talk more about that.
Go
ahead.
To go back to what we were talking about earlier about collecting the data, right? Like, so developers need so much data to understand how their applications are performing and troubleshoot things. So we collect a lot of logging data, which can have really, really detailed information in it. It can also have errors in it. So, one of the things we do is, we collect the errors and we're looking for unique errors. So it's like, oh, we did a deployment today. Well, a few minutes later after the deployment, we want to see, did we get new errors that we weren't getting before? Did we fix some errors? Like all that sort of stuff. Mm-hmm. And then we talked about collecting the APM data, so understanding performance, which transactions happen the most, what causes those transactions to be slow. It's this database query gets called way too many times, gets called in a loop. It's an N+1 problem, or it's just very slow, all that sort of stuff. And so it's just the combination of all this stuff, from the metrics, the APM data, the errors, the logs. Developers really have to have all of that information together to really understand how their applications are performing and then troubleshoot problems. Otherwise, you just have kind of one piece of the story.
Yeah, that makes sense. I think another part of this is, to tie this to our last episode. In the past episode, we talked with Max Sklar about Bayesian models, about generative systems, and about some of these machine learning things. And you can imagine this as being sort of a generative model. So you could look at, the past, let's say, 30 days of your application and say, in all of these days, I saw this one error message, about 20 times. So maybe 20 plus or minus 2, right? And then now you're on the next day and you see that same error message 400 times. And so, if you had some kind of generative model, it would have expected you to see that message 20 times. You saw it 400, and you could flag that and say, hey, this print with this message is going crazy today. You should take a look at that. And that might be a way for people to find the needle in the haystack, right?
Absolutely. And, so machine learning, anomaly detection, all that stuff I think is very useful. The challenge we have, though, is that the big problem is that software changes, right? If you deployed some software and you literally never changed it, those patterns would be probably extremely useful, because you just expect the same kind of pattern of usage over and over. And that stuff is great. You're absolutely right. But the problem with everything to do with software development is agile development. The more stuff changes, the more it breaks, right? I don't know about you guys, but how many times you're like, hey, we're doing a deployment today, and you all stand around in a room, stare at each other for a while, and you're like, are we really going to do this? Are we going to ruin our night? Especially are we going to ruin our weekend? Is everybody really sure about this crappy code we're about to deploy? Right? That's the nature of software development. And now we want to do deployments every week or every day. And you have crazy companies like Facebook that I think do deployments every 5 minutes, it seems like. And those events are the problem, right? And so that's why tools like Stackify and all this data we're talking about are so important, because they help give you more visibility, they give you more confidence, and they help you understand your risk, right? You're like, well, we know we're going to deploy this. None of us feel 100% about this thing, but we know 5 minutes after we do the deployment, we have all the data we need to understand that all of a sudden there is nobody using our software. It doesn't work anymore. It crashed. Or it's getting all sorts of new errors, or performance is, dramatically worse, right? So that's really important for all developers to have access to this kind of data, because it helps them know when they do a deployment, did things get better or worse? Did we just jump off a cliff? Is the system down, right?
How do you deal with that? So let's say there's a deployment and things change. You don't really know whether the change is normal, the deployment caused, the system to just behave differently, or if the change is a problem. There's really no way to know, right? You just have to kind of tell developers about all the changes, right? Or is there, how can people be smart about that?
Well, I think in general, it comes down to having good application monitoring. So you have some baselines, this application gets 35,000 requests a minute. Kind of to your point earlier, there's a very steady amount of traffic, on a monthly basis. It's very kind of predictable. And that's, hey, we did a deployment. Okay, well, 5 minutes after the deployment, are things normal? Is the average, transaction times are normal? All that sort of stuff, right? And able to just see, hey, things are behaving in a normal pattern. Or all of a sudden things are just totally different. Something has totally gone off the rails. Oh, okay, things have gone totally off the rails. Well, hopefully, if you have the right data and the tools, products like Stackify and these things, right, you can go and it's oh, wow, this database query is performing terrible now. And I can clearly see, the software will tell you, wow, this query sucks. I don't know what happened, but when we did the deployment 5 minutes ago, all of a sudden, this database query is crazy slow.
Got it.
And then that helps give you something to pull on, right? Like, okay, well, let's figure out what changed. Let's go back and see what was in the release. And you're like, hey, Joe, did we change this thing, right? And you start going down, because almost every single time in software, if there's a problem, it's because something changed.
Right.
Like crap just doesn't randomly break. Like that doesn't really happen. Maybe a server goes down, or AWS.
Or there's like a Super Bowl ad. And your server just blows up.
Yeah. But usually it's something changed, right? And we have to figure out as fast as possible what changed, right? And that's going back to kind of where we started the conversation, is agile development and these rapid deployments cause a lot of change events, and that's where all the risk comes from. And I'm a huge fan of doing deployments actually more often, because then you're shipping fewer changes at a time, right? You're like,
that's right.
We did a deployment, but we only made 5 changes. So it's like, it was one of the 5 things.
Yep.
Where if you do a deployment,
if you can slow roll it, even better, right? So at any given time, you have 10, 20 different deployments at the same time, and you can compare and contrast all of them.
Yeah. Where if you do a deployment and you change 50 things and something doesn't work, you're like, oh crap, where do we start?
Yeah, there's no place. So, and I have to confess, I've never, I haven't done a lot of DevOps. I find those people like SREs to be like just total magicians, and I think it's amazing. But this already has kind of taught me a lot. Can you kind of walk me through the user experience here? So let's say they've set up Stackify, they're logging a ton of stuff. How did they, like, what's the reporting look like? Is it a bunch of graphs? Is it some SQL database where they can write queries? I mean, like, how do people actually triage this? What are they seeing when they do that?
Yeah, products like Stackify are a lot of dashboards and reporting. So, a lot of analytical just dashboards and stuff. So you can go in and pick a specific application and then immediately see, okay, how does this thing perform over time? How much traffic does it get over time? On charts and graphs and stuff, and be able to quickly see, these are my top performing, worst performing things that get used the most, all that kind of stuff. So, a lot of things kind of very quickly bubble up to the top. And usually people use products like this in 2 modes. They're either being very reactive. They're like, okay, we did a deployment and the whole building is on fire. Everybody's running around. Everybody's stressed out. We're all not sure if we should just get our resumes up to date and just go find a new job. Or do we fix this thing, right? And so you're very reactive and you're trying to find the problem, right? That is one use case for all this kind of stuff. The other side of it is being proactive. It's more the Boy Scout mode. It's like, okay, how do we improve our software? And this is kind of the role of SRE today, of like, okay, we get 30,000 requests per minute. How do we make this thing faster? How do we, make it less fragile? How do we make it so it costs less for us to host? How do we improve our user experience? Like all those sort of things, right? And proactively just trying to figure out these sort of things. And amazingly, when people don't use APM type of products, they don't know what they don't know. It's like Schrodinger's cat. Like, is the cat alive or dead? Is the bug in our software alive or dead? Does it exist or not? We don't know. And maybe we don't want to know. But then you install, products like this, and all of a sudden you start collecting all the errors in the software, and you're like, holy crap. There's like 300 errors on our software being thrown. 300 different errors, not the same one 300 times, but 300 different errors being logged in our software every hour. You're like, oh my God, we got some crappy code that's doing some dumb things, null reference exceptions everywhere, just like, oh my God. And it's like Schrodinger's cat kind of thing. Like, you don't know what you don't know until you know, and then you sort of don't want to know.
Yeah, you find out. Yeah, I think it's so true. When I'm writing code, especially as I've gotten more experience, I'll put logs. I'll be much more diligent about writing logs, and I'll get to a point where I'll say, you'll never actually get here, and I'll just put a log saying, we'll never get here. And then, a year later, you go and look at the code, or people send you the traces, and it's always like should never get here. I don't remember why this should be 3 and then :2, right? I mean, it's just like, and it's just terrifying. And so, yeah, to your point, it's kind of, you build up, and then people leave the team too, right? And so that intellectual capital is gone, right? And so definitely, bite that bullet as soon as possible. Otherwise, it just gets so hard to go back and recover.
Well, and I have a particular saying that I'm very fond of that I think every developer should have tattooed right on their forehead. And it is, if it can be null, it will be null.
Yeah, that's so true.
Okay? And it goes back to the point of you just mentioned, like, this thing shouldn't happen, but it could.
Yep.
And then what do we do if it does happen, right? And it's the same thing with things being null. Like, everybody thinks code is perfectly magical and there's like puppies and clouds and rainbows. But 1 in 1,000 times there's not. And what's great about software is if it works 99.99% of the time, it works perfectly, right? That means like 1 in 10,000 times it fails miserably. And that's perfectly acceptable. We live in this world where like 1 in 10,000 airplanes could fall out of a sky and it's okay. That's software development for you, right?
Yeah.
And that's the reality of software too, is there are problems all the time that you do not anticipate. You cannot anticipate, but you have to try. You always have to be defensive in your programming. To your point earlier, like, we add this logging in here just in case this weird scenario happens, or something is null that we didn't expect to be null, but you have to account for it, because if it can be, it will happen. It happens every time.
Yeah, to give a first-hand example, I mean, we rolled out, I rolled out the Eternal Terminal, which is this SSH alternative. And one thing I didn't expect was people running out of memory, because I'm looking at my desktop here, has 64 gigs of RAM. My laptop has probably the same. And I didn't really think about, Eternal Terminal uses maybe 50 megs, right? But someone out there was running it on a VM that they got for free, and just all things started breaking all over the place. And it's because every time you ask for memory, you could end up not getting it.
Yeah.
It's just that stuff ends up being really difficult to do after the fact.
And you're adding to that topic, we never think about performance these days because computers are fast and we have fast internet, right? But what happens when you're working on an airplane that's flying over the Pacific Ocean that has the worst Wi-Fi connection in the entire world, and you're trying to use a website, right? Yeah. You're trying to surf the web or do something, and it's like the slowest thing in the world. But as developers, we don't think about those scenarios.
Yep.
It's all those sort of scenarios that we never think about that then cause all sorts of errors and bad user experience. But
yeah, and that's where I think tools like Stackify are really important, because they give you a window into the entire user base. And Absolutely. There is that needle in the haystack, which we talked about earlier, and that seems pretty overwhelming. But with the right tools and the right logging, you can actually find that person who maybe right now is flying over the Pacific using your app.
Well, you mentioned your logging. Logging is really important, but it's even more important to do the right type of logging and using logging levels. So it's like, that weird scenario you mentioned, that needs to be logged at like a warning or error or fatal level, right? Not a debug level, and that's where when people's apps get deployed to production, a lot of times debug logs and stuff aren't turned on because they can be like a crazy volume of information. But you need to look for things that are warnings or error or fatal and those types of severity. And then it makes it easy to log into a tool like Stackify and say, okay, let's look at all the logs that are warning or fatal or whatever, and go find those problems.
Yeah, that totally makes sense. What about how do you handle machines that are misbehaving? So in this case, if you look at the overall data, it might be fine. But I remember an issue that we had a number of years ago where basically our app was creating new threads, and so it's just constantly creating new threads. And at some point, the machine would die, and AWS or whatever the cloud we were using would just kill that machine based on some logic they had, and then it would spin another one up. And so it's one of these things that it took us a long time to even know something was wrong, because you can't really tell. But if you were to look at a single machine, you could see that things were getting kind of bad, right? And so How do you handle that where you have this sort of heterogeneous environment where some machines are healthy, some aren't?
So I had this exact type of issue happen this week at Stackify. We deployed a new application on Kubernetes in our QA environment, and for whatever reason, the pod would fail, and then Kubernetes would restart the pod and create a new one. Except the problem is it did it 7,000 times over like 3 days, and then Kubernetes ran out of memory.
No, okay.
The node in the cluster like ran out of memory. Now, luckily this was in QA and it wasn't a big deal, but these things happen. To your point, like things that you don't anticipate, and actually the fix for that was we had just put memory limits on the pod, and then it behaved just fine. Like just really weird stuff.
Oh,
and to your point, like these are problems that still happen. We've got another app in Stackify that's actually in production for us, and the only way we can make the thing work is to restart it every 30 minutes.
Oh no, that's so brutal.
But these things happen, right? And you're like, okay, do we spend like millions of man hours and dollars fixing this thing, or do we make a script to restart it every 30 minutes?
Yep. Yeah, that is a really good point, right? It's especially when we dive into this, it's easy to kind of say, well, we'll log everything, we'll do a deployment once a year or something like that. But there's always these trade-offs, right? And so, it could be that if your business doesn't move fast enough, like if you're not pivoting based on the user experience fast enough, that you fail at the business level. And so you're kind of running up against that. You have to kind of balance. And this is one of the things that I think a good tech lead will do well, is balance sort of moving fast or maybe being sort of more interactive with the other cross-functional teams. Balance that against accumulating all this technical debt. And so I think that's like requires constant supervision.
Well, and we could record a whole podcast episode just on this topic, but the problem is software developers always chase shiny objects, right? They're like, hey, we want to rewrite everything in Kubernetes because why not? And so we redo everything with Kubernetes, and then like a year later, they're like, nah, let's move to AWS Lambda. That's even cooler now, and it'll look better on our resume. So then it's like, let's just spend the next. No, we're literally not going to ship a new feature. We're too busy. We're moving everything to Kubernetes and Lambda, right? Like that's what people do this, and then they never deliver new functionality to their customers. You're absolutely right. Like I said, I could go on this topic for like an hour.
Yeah. And I know I have a friend who works in the games industry, and he says, I asked him really to describe what this crunch phenomena was. This was around the time when there was a lot of publicity around the crunch hours that game developers work and things like that. And he basically explained to me really well. He said it's basically feature creep, except because a game is kind of this atomic thing where you just release the game. It's all hypothetical, right? So the game designer will come to the engineers and say, oh, we need to add a 14th lineman in Madden, otherwise like no one will play this game. And then they go and they like code it up, and it's like, oh, now the football needs to be orange. It has to be orange. Everyone loves orange. And then, oh, now we want the person to be able to set the color, right? And so you get all of these changing requirements, and you're working these insane hours. And so then, that's one of the reasons why I think code quality on games has always been a challenge.
Yeah, feature creep is a never-ending problem in software development. And to some sense, developers our own worst enemy on it too. Where I'm talking to one of my team members this week, and we use like a SQL parser that parses SQL statements, and we're having problems with it. And I'm like, okay, well, and we use like a third-party product to do this. We're like, okay, well, if it doesn't work, we have some fallback logic, and we'll just have this really little regular expressions that are fallback logic. But my developer's like, no, we need to write our own SQL parser, and I'm like, no, we don't. No, we really don't need to do that. We have other stuff to do.
Yeah,
but that's what developers do, right? Like,
well, people love building stuff.
Yeah, we're our own worst enemy of what I always say, like doing software development sideways. Like we're not moving forward to like really improve our product and deliver new stuff to our customers. We're just like moving sideways. Like, okay,
actually, I wanted to piggyback on that. So you make a product for developers. When you started Stackify, were you afraid of that? Because that's one thing that I've always wondered. And we talked to a lot of folks who make, who for whom developers are the end user. And one of the fears is that, you can provide 99% of the functionality, and then the developer says, no, I want to build my own Stackify for my own company, right? And so how do you defend yourself against that?
I mean, there's really nothing you can do. At some point in time, you just have to say no. And this is actually something I have to remind our teams all the time. Like, our customers will come to us and like, oh, Stackify doesn't work in this like purple squirrel mode. And we're like, nope, sorry. Yep, it doesn't. And we're not going to fix it because our other 99% of our customers don't care about that. And we're not going to bet our entire company on that 1%. Like, the other 99%, we have got to service, right? And we've got to make an incredible product for that 99%.
Yeah, when you started Stackify, how did you know that these people would use it and not try and build their own thing?
Well, I mean, when we first started out, what we were doing was a little different, right? And I think maybe developers these days, compared to maybe say 10 or 15 years ago, are maybe a little more over of the like, I'm going to build my own version of this. I mean, I think that was definitely the case like 15 or 20 years ago. You're like, oh, we need some little JavaScript library or some little library that does this or does that. And yeah, developers were really bad about like, oh, I'm just going to create one instead of buying one for $400. And maybe because things now, there's so many like SaaS products, like it doesn't, like there's no way, like if somebody wants to rebuild Stackify, good luck and I'll talk to you in 5 years. Like there's just, it's so complicated. Like I was like, good luck. It's not like some little JavaScript library that does this one cute thing like change currencies or time zones or something. And maybe that's the difference, right? Like so many SaaS products, like you want to create your own version of Twilio or SendGrid, like good luck, go for it. If you want to master that, go for it. It just doesn't make any sense.
It'll take you 5 years to make emails that don't go to spam.
Yeah, good luck.
That alone.
And to be honest with you, that's the most amazing thing about being a developer these days is we have Azure and AWS and all these different platform as a service stuff and APIs that we can use for things like Twilio and SendGrid or machine learning or a thousand other things that are just make it so much easier to build software and not have to reinvent all of those wheels. Writing software today is so much easier because of all of those things. But then it's so much more difficult for other reasons. Yeah.
I think it's people just are much more productive, and then because of that, I think it's much more lean. You could have 3 people do an entire. There's this I can't remember the name of it, but there's this social network it's kind of like a TikTok thing, but it's audio only. I can't remember the name off the top of my head, but it's literally started by 3 people, and they recently raised I think 20 million. And they have a ton of users, and it's just 3 people, and they were saying they don't even really have any incentive to hire a bunch of people because it's already they've scaled it up themselves.
Yeah, absolutely.
So let's talk about Stackify. What is the company like in terms of where do folks work? Is it sort of distributed? You have a lot of folks here in college that are looking around for internship opportunities. Do you all do internships? Are you hiring full time? Kind of like walk us through the company, maybe even like what a day is like working at Stackify.
Yeah, so we have about 45 to 50 employees, and about 25 of those are in the Kansas City area, and then we have about 20 employees in the Philippines. So we have a lot of our engineering is done in the Philippines, and then we do customer support as well and some other things out of the Philippines. And part of that is because Stackify is a global company. We have customers in 60 countries, and so we have to operate 24 hours a day. So we have support people and developers 14 time zones different on purpose.
Yeah. Wow, it's wild.
So we can help support, our customers globally. But, at Stackify in Kansas City, we hire a lot of entry-level developers to do support because our product is so technical. So we actually hire developers to do like customer service, customer support. It's like really high-level kind of technical support for our customers. And then a lot of times those developers then work their way potentially into our engineering team. And so I think that's a great career path for developers is to work in that kind of like tier 2, tier 3 kind of customer service and high tech companies, learn the product, have like really invaluable product knowledge that way, and then be able to bring that product knowledge and customer kind of viewpoint right into the engineering team, and then continue to grow their engineering skills. I think that's a great career path. And we had a developer at Vin Solutions that did that at my old company, came in as entry-level support, worked his way up through all the support, became an engineer on the team, and then left and founded his own software company. Now he has his own software company he started. And so I think that's a great career path for people.
Yeah, that makes sense. So the folks in the Philippines, like, how do you deal with 14 times? We have trouble. I'm 2 time zones away from my boss, and we have trouble with our team. How do you deal with 14 time zone difference?
So we have some people that work our hours in Kansas City hours, so that's full. They work like the graveyard shift there, like overnight shift there. But most of them actually work there like 3 p.m. to midnight their time, which overlaps to like 11 in the morning Kansas City time. So we have meetings and stuff like that with them in the mornings. And then we have. How
do you keep the cadence up, right? So let's say you meet once a day. I've seen issues where, and these are people who are only 100 yards apart, right? But they'll send an email, the person will respond the next day, they'll respond the next, and it's just nothing's getting done. And you finally have to say, okay, we need to just sit together. And I found that to be a recurring problem. How do you handle, how do you close that loop?
I think those are all communication and management problems, right? And, that's the great thing about Slack and things like that, being able to communicate with people instantly and get work done and collaborate. And a lot of the challenges that you mentioned are totally different now that everybody's working remote. And working remote, I don't know about you guys if you've ever worked remote or been on a team that was partially remote, but I think the worst case scenario is you've got 5 or 6 people on a team that work together, and then you have one person who works remote.
Right.
That one person is always in the dark and they will never know anything, right? Because the other 5 or 6 people are in one room, and when one of them breathes weird, everybody knows what they're thinking. Because, there's that osmosis of just that teamwork, right? And being together and just knowing the personalities of people and all that sort of stuff. But now that we're all working remote, all of that has gone away. Like the communication style has to change dramatically. And now that one person in my example before that was the odd person out that was always in the dark, now all of a sudden it's a level playing field. Like everybody has to communicate in a different way. And the big thing that people have to strive for is just the sense of urgency. It's like, I need so-and-so's help to figure this out. I could email them and just pray that they respond eventually, or I could call their butt right now and get a damn answer and figure this out. And what I always used to say when we're all in the office is I'm like, go sit on their desk until you figure it out. Like, go figure it out now. And
I feel like
that sense of urgency is the key.
Yeah, I feel like what I've noticed, and I've noticed this in myself too, is sometimes you could end up like subconsciously procrastinating, where it's not like it's a big deal. It's not even really procrastinating. It's subconsciously not unblocking yourself. So you hit this roadblock, and you don't even really know it's a roadblock. Like maybe it's some technical problem that you don't know how to solve, or maybe it's a person that you need to talk to, but you don't quite know who to talk to. And so you just end up paralyzed. And if you ask somebody, like, hey, what's the status on this? They'll say, oh, I'm working on it. And then at some point you kind of realize, oh, no, this is actually blocked. And there's some like state of like unconscious misunderstanding, right? And I think actually, to your point, being online might actually make that easier. Because when you're in person, you might see the person kind of stressed and say, "Oh, this person must be working really hard," right?
Or really I can tell I need some help.
Running into a wall. Yeah.
I think there's always a delicate balance to this, right? Because you don't want to be bothering people all day long and asking them dumb questions that you can answer on Stack Overflow. But at the same time, you don't want to sit there and be marinating on problems and not getting anything accomplished because you're not asking for help. There's definitely a very delicate balance there, and it's always a struggle. And
Yeah.
I always tell my developers on my team that it's like, if you need help, ask. I'd rather you ask for help and be overly annoying about it than be sitting there wasting a bunch of time. And I think, these things are the reason we have stand-ups and different things like that on a daily basis is not necessarily because we need them, because if you had the right people that are good at communication, they would ask the questions. But it's almost like we have stand-up every day because some people aren't very good at communication, and it's that chance to say, hey, do you need help? Because otherwise they won't ask for help. And otherwise, right. If you have all the right people on your team, stand-ups maybe are completely useless. But for some personalities, it's that daily check-in that you need to push that, to make sure that, those questions are being asked.
Yep. So on the product side, if someone, let's say a college student or someone just getting into programming wants to use Stackify, what is that? I mean, I understand that Stackify is like mostly for enterprise, right? But for folks who want to get started, what is the sort of tier look like? Is there a free tier? What's the environment like for someone who is just an academic trying to get into this area?
Great question, and I've got a perfect answer for you. So actually, Retrace, our flagship product, our APM product, Retrace, starts at $99 a month. So it's very affordable. It's not like a really expensive enterprise product. We have another tool called Prefix, which is free. And so I honestly think it's the type of tool that, you talk about like in an educational perspective. It's very, very useful in an educational perspective. And we have some colleges and stuff like that use it. It's a profiler basically that runs on the developer's laptop. So as you're writing and testing your code, you can instantly see what that code just did. So it'll show you, okay, this page loaded, this transaction loaded, it ran this database query, it did this web service call, it did 3 more database queries, and here's how long it took, and show you your log messages and everything. So it kind of gives you like instant feedback to what did my code just do, and did it work? How long did it take? All those sort of things. And then that's a free tool that Stackify provides. It's called Prefix, and I definitely recommend it.
Got it. So the idea is someone's just getting started. They probably don't know about Docker and all of this yet. They're SSH'd into some AWS box, and they are developing some website or something like that. They run Prefix. Is it hooked into VS Code, or where does Prefix actually live?
So usually it's used on your laptop itself, like not on a server. It's on your workstation.
Oh, I see.
And it's installed the same kind of way that Retrace is. So let's say you're using Python, you would install our package into your app, and then that would enable the monkey patching and the profiling that we kind of mentioned earlier. And then Prefix will collect that data all locally and just show it to you all locally. It doesn't.
Oh, got it. I see.
It doesn't connect to the internet locally, or any of that. It's all local.
Yeah, you're testing locally. You have like a local database, or using SQLite or something simple. And you're running the same thing you'd run in production, but in this test environment. And while you're doing that, Retrace is telling you, like, oh, you're really hammering the SQL server right now. You might want to take another look at what you just wrote.
Yeah, and that's what Prefix does. That's why we call it Prefix.
Oh, Prefix. All right, that's clever.
So
cool. Yeah, that makes sense. Hey, that's awesome. So everyone out there, check it out. Totally free. I guess it runs on everything like Windows, Mac, Linux, stuff. Maybe Windows, Linux.
As of today, Prefix has primarily been for .NET on Windows, but we're getting ready to release a new version that will support 6 programming languages and also run on the Mac. So
cool.
Look for that very soon.
Very cool. Yeah, keep your eyes peeled for that. Also, you have a podcast of your own, which is really cool. We're totally going to check this out. Why don't you give us some details about the Startup Hustle and what that's all about?
Yeah, so it's called the Startup Hustle, and you can find it on Apple and all the places you would find a normal podcast. And it's about entrepreneurship and startup stuff. So we cover a lot of different topics related to startups, and we have a lot of different guests that are founders of other companies, and just if you're kind of into the startup, you're an entrepreneur, it's a very educational podcast.
Cool. So what advice would you give for someone coming out of for someone who doesn't have a college degree or doesn't have a degree in computer science, and wants to get into this field, what do you think is the best way? There's these coding boot camps, there's DIY, there's all these, you DIY and then go to a smaller company where you don't need the fancy college on your resume, right? There's all these different sort of approaches to get into the field, and it'd be great to hear your take on which one you think could be the most useful for people.
Well, like almost all things in life, you've got to put the effort into it. You got to work. Like instead of Netflix and chill, you got to figure out, how do I make a website for my church or whatever, right? Like you just got to put the effort in and get experience any way you can. If it's like, look, I'm going to find a local startup and I will donate my time. What can I do? Please. Anything I can do, I want to write some code and dedicate. It doesn't matter. Like I need experience, right? And that's the hardest part as a developer. It's a chicken and egg problem, like a lot of things, right? Where nobody wants to hire people without experience, but you can't get experience if you don't get a job. And the great thing about software development is you just need some experience, and that could be, helping some local startup or, somebody else in the community or some business, an open source project, whatever it is. You just got to get experience and you got to put in the effort. And a lot of times I've had developers that work for me or employees that work for me that want to do software development. And I've actually got one now kind of on my team. I meet with him and he's like, well, I really want to do computer programming. I really want to do coding. And I'm like, well, why don't you do it? You're not putting in any effort. You're not coming to me and asking me like, hey, do you have a project I can do or whatever? Like, you got to put in the effort. And that's the number one problem with everything. You got to put in the effort.
Yeah. So what do you think people should do to prepare, if anything? Right. So I think, a lot, there's so many of these, like there's Udacity and Coursera, and then there's real life, like brick and mortar, coding boot camps where they kind of give you a diploma at the end or get you some interviews. And the sentiment on this has been pretty mixed, right? I mean, there's some people who swear by them. There's some people who say, oh, I don't even look at that on someone's resume, and they disregard it totally. I think that, you can easily learn everything on your own. And so, what do you think is the value of these kind of coding boot camps? And, would you advise people to try them out?
So I think all of these things are applicable avenues, right? So, there is a boot camp sort of place here in Kansas City that I think is like 12 weeks long. And but it costs like some insane amount of money to go to. Like it's like $20,000 or something like
wow.
It's some astronomically stupid amount of money. But you know what? Like 90% of the people that go through it get a job.
Oh.
So somehow or another, they do a really good job at placing these people. And now they don't all necessarily get engineering jobs. They may get jobs doing QA or technical support or other things, but they're entry-level positions. That's the key, is getting your foot in the door somewhere and getting experience. And so, I think the cost of those things are insane. Yeah. But with all of these, it's like the ROI to it, right? It's like if I know if I go to this thing and I'm going to get experience and they can help get me a job, then it's really valuable. So I actually went to DeVry, which is a technical school. You end up getting a 4-year degree. Mm-hmm. And, they do a good job as well with career placement and stuff like that. So, but I think all of these avenues are possible. I think some of the best are working at a place and you've got like product knowledge, industry knowledge of a certain thing. You're like, I want to teach myself programming. And then like, okay, how do I apply that where I work, and then how do I like ease myself? How do I somehow transition myself from being, I work in a medical lab and I'm an expert on all things about medical lab. How do I work myself into the engineering department somehow, right?
Yeah, and that's really good advice.
And that was my example earlier from Vin Solutions. Like we had somebody who was a support person, and they slowly work themselves into the engineering side of it. And that's where you can teach yourself or do small projects. You're starting to work on small bugs. But a lot of times you got to work at the right kind of company that has the right atmosphere for those kind of people to succeed too.
Yeah, and I think a lot of those are startups. I think startups are a really good place for people to go. And in fact, I have this sort of theory that sort of the better you are relative to your resume, the better a startup is for you. So, if you have a phenomenal resume, but you're not actually that good at coding, then going to a big company is probably going to work in your favor. You can kind of blend in, the resume will carry you through. If you're lopsided in the other direction, you have a ton of talent, but you got a degree in economics or something, and so the degree doesn't show the computer science skill that you have. That's where startups can be a really good opportunity. I also really like what you said about starting in an adjacent role. A lot of people ask me how to get into AI, and I tell them something very similar, which is just start as a software engineer at a company that does AI in some way, shape, or form. That's usually the best way to start.
Well, or it's like, hey, I'm a software engineer at Stackify, and maybe we don't do a lot with AI, but in my free time, I'm going to see how I can apply AI to what Stackify does.
Yep.
Right? I'm going to go back to my boss and say, look at this really cool thing we can do with AI.
Yeah, totally. Cool. Yeah, I'm definitely going to check out your podcast. I just inside baseball or something. I've always wanted to start a company. It's never been the opportunity hasn't presented itself to me yet, but it's something I've always been interested in, and I love resources like that. I follow what's the one I follow? Oh, Pivot, where they talk about a bunch of different startups. But yeah, I'll add this one to my list of podcasts. I'm looking forward to it. And thank you so much for coming on the show. So folks out there who want to know more, the tool that was free is Prefix. Yeah. There's also, what is the enterprise product?
It's called Retrace.
Retrace. And you can get both of those at stackify.com. Check it out. And what is Python? What are the 6 languages that Prefix is going to support?
Yeah, so we support .NET, Java, PHP, Ruby, Node.js, and Python.
Cool. I mean, that covers a lot of the major ones. So once that's out, maybe we'll add it to our news section of the show when that's out. So we'll remind everyone about that. And thank you so much for coming on the show, Matt. I really appreciate it. And I think hopefully we really showed a lot of folks out there how this actually works and how these websites stay up.
All right. Thank you for having me.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.